All right. Hello, and this is the next video. Welcome to Chem with Com, and this is another video. We're going to keep going on atomic structure and significant figures, but specifically, we're going to tackle atomic mass and math with significant figures. All right. So, quick thing. I know chemistry is difficult, but you can do it, and you will be successful if you can commit the time required to it. Chemistry requires a lot of time, consistent practice, not once a week. You want to do this as often as possible, once a day, twice a day, whatever it takes. Repetition, just because you did it once doesn't mean you know it. You got to practice it, and you got to have a lot of patience with yourself. If you can do those things, you will be successful in chemistry. All right. So you can do it. Pep talk over, but I believe in you, and let's get going. All right, we left off talking about isotopes. Isotopes are elements with the same number of protons because they have the same atomic number, but they have different numbers of neutrons. This hydrogen has 0 neutrons. It's this mass. One hydrogen, this mass. Sorry, one neutron, this mass. Two neutrons, this mass. Same with helium, right? Helium, there are two isotopes, atomic number of 2, which means 2 protons each. Helium-3 has 1 neutron with this mass, and helium-4 has 2 neutrons with this mass, right? So we're going to figure out what to do with this, and we're going to calculate the atomic mass, which is the average mass of all the isotopes of an element. So we're going to get those different isotopes. Like this one has a mass of 10 something. This has a mass of 11 something. And these are the natural abundances. Natural abundances are what the percentage of these isotopes we find in nature. That's the way we find it. So, this is how we're going to calculate the average mass of all isotopes of an element. Specifically, this is going to be boron for this example. So this is how you calculate the average mass. You take the fractional abundance times the mass, and you add that with however many times you need to do that. Here, there's going to be 1 and 2 times. And we're going to have to figure out how to calculate this in the proper order. To do that, we're going to follow what's called the order of operations. And we do certain mathematical operations in certain orders to make sure that the calculations are consistently the same and that everyone follows the same rules so that we all get the same results. Here we're going to start with an acronym called PEMDAS. So P is for parentheses. You can see the parentheses here. E is for exponents. That's something like this, x squared or 10 to the 5th, right? It's that number up there. It's an exponent. Multiplication, that's kind of common. So that x is a symbol for multiplication. And division, it's something like, 5 divided by 2 or 5 over 2. That's multiplication division. And I have an arrow over that because we want to do multiplication and division at the same time, but from left to right. Addition and subtraction, we want to do at the same time from left to right. So we're going to use this to be able to calculate this equation properly. Something else we're going to deal with a lot is this equation, percent equation. It's the part of something divided by the whole thing times 100% equals the percent. So we are going to use that, and yeah, right now. So let's figure this out. So it's the fractional abundance. That's the fraction. This is called the percent natural abundance. So we have to go from fraction to percent. Well, this to me looks like a fraction. So let's use this to calculate the fractional percent, or the fractional abundance. So I'm going to rewrite that. Fraction times 100% equals percent. And just so I don't forget, the secret word of the day is, or for this video, is max. M-A-X, max. Secret word of this video is max. All right. I'm going to do the rest of the calculations with a blue pen so that you can see what I'm doing. And actually, let me, um, I'm going to rewrite this with the terms that we're actually using. So here we're going to say 19.9%. I'm just going to put a line here because we're starting something new, but it's going to be fraction times 100% equals 19.9%. All right. So we're going to divide both sides by 100% to get rid of that 100% on the fraction because we want to solve for the fraction part. So here 100 cancels out. Here the percent signs cancel out. Here on the right side, just the percent signs cancel out. So when you get your calculator and you do the math, it becomes 0.199. And that's how you calculate the fraction. Right? So that's where the 199 comes from. This mass is this mass. Right? So let me box that up just so you could see it. And I'll make this a triangle so then we could see that's where the triangle. So if we do the same fraction calculation, that'll get us there. And then I'll just put a dotted box around this one so you can see where I got this one. Oops, sorry about that. I guess I was clicking too much. I wonder if it does it again. No, okay. All right, so that's where we're getting our numbers from. So let's do the calculations. All right. So we're going to do things again in the parentheses first. We're just going to go left to right. We see parentheses. We'll do that first. 0.199 times 10.0129. I got 1.992567 plus 0.801 times 11.0093. And let me finish that up. So we cannot leave out that AMU, right? That's a unit. And it's almost like having a variable. So that can't just disappear. In chemistry and all sorts of other sciences, physics, biology, you can't just leave units out. You have to have an excuse to cancel them out or have a reason why they disappear. You can't just leave them out. So we have to keep it in there. So I have a bunch of numbers here. And again, a number times a number with a unit is going to be that the unit's going to stick around. So now we're going to add those together. 1.992567 plus 8.8184493. I got 10.8110164. All right. So again, we did parentheses first, and then we did addition because that's what was left, right? We're going to go in order. So parentheses, exponents, multiplication, division, addition, subtraction, and this is what we ended up with. AMU. Okay. If you look on your periodic table, they're only reporting this number here. Now we have to figure out why. So now we're going to do math with significant figures. All right. So significant figures, when we're doing these operations, when we're doing addition or subtraction, we're going to use the least amount of decimals in the problem. When we do multiplication or division, we're going to use the least amount of sig figs in the problem. All right, so addition, subtraction, least amount of decimals, multiplication, division, least amount of sig figs. Easy to get this tripped up. Again, take notes, write them down. You want to practice this. And then sometimes you have both. So if it has both addition, subtraction, and multiplication, division, you're going to use both. We're going to use what's called an overline. So like a line on top of a number. Let's see, 0.3. Let's say this had 3 sig figs. We're going to put an overline there and keep track of the sig figs and then just keep doing the operation. That's the only new thing we're going to do. All right. And we have to round. If the digit to the right of the last sig fig is 5 or greater, we're going to round up. If 4 below, we're going to round down. And there's other rounding rules you're going to learn in the future that's a little more intricate, more specific. But for now, we're just going to use these kind of more simple rounding rules. All right, so let's try this. Let's go back to our problem. And it says 0.199. So let's do this first. To me, this is, let's do this first. So we're going to say 0.199 times 10.0129. 10.0129 AMU. We're just rewriting the problem from before. And then I believe this is 80.1. So we'll put 0.801 times 11.0093. 11.0093 AMU. So according to PEMDAS, remember that? Parentheses, exponents, multiplication, division. Oops, sorry about that. Touched the wrong part of the screen. I'm just going to put them here just so we don't tag out of the screen anymore. But first thing we're going to do is the parentheses. Inside that parentheses is multiplication or division, specifically multiplication. Let's do this. 0.199 times 10.0129. I got 1.99256671 AMU. We're going to look at the significant figures in the problem. There's 1, 2, and 3. So this is 3 sig figs. Here is 1, 2, 3, 4, 5, and 6. So 6 sig figs. All right, so for this answer here, 1.9925671, we're going to use 3 sig figs. All right, and then we're going to do future calculations. Now, we don't want to round too early. So what we're going to do is we're going to put a line here that says, hey, this is the last significant figure in this answer, in this number, right? Because when we do multiplication, we use the least amount of sig figs. We ended up with 3 sig figs as the least amount. So we're going to use that number. Let's do the same thing for the next problem. So here we have 1, 2, 3 sig figs. And here we have, again, 6 sig figs. So we're going to use 3 sig figs in the answer. All right, 0.801 times 11.0093. I got 8.8184493 AMU. Okay, we're going to use the 3 sig fig thing again. I'm just going to put a line there. Okay, so now when we add these together, let's move over here and we'll say 1.99256671 AMU. I'm going to put a line over the 9 because that's our third significant figure. 8.8184493 AMU. And I'm going to put a line over here because that's our last sig fig for that problem. And we're going to add these together. Here we want to use the least amount of decimals in the problem. All right. So here I'm going to say we have two decimal places. Here I have two decimal places. So our answer should be in two decimal places. All right, let's add this together. So we have 1.9925671. Put that in my calculator. I got plus 8.8184493. And then our answer is 10.8110164 AMU. So since we have two decimal places, 1, 2, our answer is going to be, and if we look here, we're going to cut it off there. We look at the 1. Since it's not 5 or above, we're going to keep it as 10.81 AMU, atomic mass units, and that's our answer. So sig figs, right? We did math with sig figs. We had to use the order of operation, the percent equation. So a lot of stuff going on here. I highly recommend rewinding this and doing it again, taking notes. But yeah, that's going to be it. So again, addition, subtraction, use the least amount of decimals in the problem. Multiplication, division, use the least amount of sig figs in the problem. If it has both, use both. Use an overline to keep track of the significant figures. Basically, don't round too early. And then you want to round at the very end. Round at very end. All right. So let's check some stuff. All right. So we're going to add these two together. Maybe I shouldn't have done that. Let's erase that. But if we're adding and subtracting, we do the least amount of decimals. So here we have 3 decimals. Here we have 2 decimals. Since 2 is less than 3, our answer is going to be in 2 decimal places. Let's add that together. 2.334 plus 0.31 is going to be 2.644. We can't get rid of the digits. It has to be milliliters. We want 2 decimal places. So we look at the 4, the last 4. We don't round up, so it just becomes 2.64 milliliters. All right. So it says subtract this number from that number. So it's I like doing subtraction actually and addition this way, but you can kind of do it how you want. I'll show both ways. And it says subtract 5.8752 meters. And I'll move that M away a little bit just so it doesn't get in the way when we're looking at stuff. All right, this is our third decimal. So we'll say 3 decimal places. This has 4 decimal places. So we're going to have 3 decimal places as our answer. All right, let's do this. Put it in your calculator. 56.533 minus 55.8752. I got 0.6578 meters. Now we want 3 decimal places. So I'm going to cut this off at this is 1, 2, 3 Third sig fig, we want to look to see if we round up. So we look here, and it's supposed to be 0.658 meters is our answer. Again, you have to do both, right? We're going to do the decimals is, sorry, addition, subtraction, least amount of decimals. So that's what it should be in your answer. All right, let's do a couple more. Multiply. This is going to be least amount of sig figs in the problem, right? So let's figure this out. This is 4 sig figs. This is 3 sig figs. And remember, the 0 at the end of a number is only significant if there is a decimal in the number and it's 0.320. So there is a decimal. So our answer is going to be 3 sig figs. So let's take a look. 2.334 times 0.320. This might look a little weird, but let's figure this out. 0.74688. Now we have centimeters times centimeters, right? So centimeters times centimeters equals centimeters squared because there's 2 of them. 1, 2, and we have 2. So this should be centimeters squared. 3 sig figs, we're going to chop the number here, and we round up to 0.747 centimeters squared. All right. This one is 55.8752. I'm going to rewrite it a small, little bit different. Meters divided by 56.53 seconds. Here we have 5 sig figs. Here we have 4 sig figs. Oops, sorry about that. So I'm going to bring that down. And look at the M and S, right? That's not going to change because they don't cancel each other out. As centimeters times centimeters didn't cancel each other out, but we had to put a 2 there because it's centimeters squared. Also, you can write this either way. This is correct, and this is correct. This one's just easier to read and see. So let's do this. It ends up being meters per second. Type that into your calculator, 55.8752 divided by 56.53. I got a big, long number. I'm going to just report a few extra digits. 0.9884167. All right. So if our numbers have 5 sig figs and 4 sig figs in our problem, we're going to use the least amount of decimals. It's going to be 4 sig figs. So 1, 2, 3, 4, put a line there. So the answer is going to be 0.9884 meters per second. All right, let's do some more practice. All right, here we have multiple operations. Let's figure this out. So we're going to say PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. All right, so we do multiplication. There's no parentheses, there's no exponents, so we do multiplication first. So I'm just going to underline this. So we're doing this first, and then I'll say first and then second. Let's do this one. A. So we have 2.334 centimeters And then to make this a little easier, what I'm going to do is, actually, let me just figure this out real quick. Okay, this is slightly different than the book because I added a little slightly more difficult thing here, but let's do this here. So what I'm going to do here is I'm going to put, so the units come out good. I'm going to put parentheses around here. And then for this, I'm going to put parentheses around here. Okay, so because we have parentheses, we're going to do the parentheses first. So let's take a look. 0.320 centimeters minus 0.12 centimeters. All right. So we have, since it's subtraction, we have three decimal places. Here we have two decimal places. So our answer is going to be two decimal places. Let's do the math. 0.320 minus 0.12. I got zero. My calculator says 0.2. But since I need two decimal places, I'm going to put a zero here. And that's going to be centimeters, right? I'm going to put, so I know the over line is going to be over 2 because we need two decimal places. All right, the second part is going to be now 2.334 centimeters times 0.20 with the overline centimeters. Here we have 4 sig figs. Here we have 2 sig figs. All right. So if we do that math, it's going to be 2.334 times 0.20. I got 0.4668 centimeters, and that's going to be now squared. We need two sig figs because they were doing multiplication. So I'm going to put a line here. It's going to be 0.47 centimeters squared. All right, let's do the other one here. Let's do B, parentheses first, 5.8752 meters. Addition, subtraction. Remember, that's going to be, sorry about that. Addition, subtraction. That's going to be least amount of decimals, but let's add that together first. 6.22 meters. All right. And then that's going to be, again, decimals. So here we have 4 decimals, 2 decimals. Our answer should be 2 decimals. Okay. So 55.8752 plus 6.22. I got 62.0952, and that's meters. We want 2 decimal places. I'm just going to put a line there. All right. Next operation is 62.0952 meters divided by 56.53 seconds. Now, since division multiplication, this is going to be number of sig figs. So this is 1, 2, 3, 4, 5, 6 sig figs. Here is 4 sig figs. So our answer should be in 4 sig figs. Let's go to the right here and just put that in your calculator. 62.0952 divided by 56.53. I got 1.098447 yada yada, and then meters per second. But we want 4 sig figs. So 1 2, 3, and 4. Sorry, let me back this up. We actually only had 4 sig figs here because we needed to take into account that overline. So because it was 2 decimals, it ends up being 4 sig figs. So here's 4 sig figs, 4 sig figs. So our answer is going to be 4 sig figs. And so that just comes over as 1.098 meters per second. And that's the total. Um, that's the final answer, right? We did multiplication and division, subtraction, all in one, and these are our answers. All right, let's continue. This one we already did, so let's move over to what's called a calculation with magnesium. This is a little harder, not crazy amount, but let's get to work here. So again, atomic mass, average mass of all isotopes. And so here we have 3 different forms of magnesium. And again, when we do the percent calculation, go back a few slides or maybe to the beginning and look at how to calculate fraction. But we're gonna poke around and get these things going. All right, so we're gonna have, it says we're trying to calculate the average mass of all the isotopes of magnesium. So this is going to be our first set of things. Again, our fraction or a percent. We're going to convert into fraction. This is our mass. This is our second thing. It's kind of in 2 lines, so it doesn't look great, but this is our second thing. And then this is our third thing. It has the percent and the mass, percent and mass, percent and mass. All right, so let's write this all as one big long equation. So just to start us off, we're going to do that percent to fraction thing. And what it ended up being is you're going to basically move the decimal over twice. 1, 2. So that equals 0.7870. Sorry if it's all squished there. Let me move that out the way. All right, so we're going to do the same thing to all of those. And let's just do it in one big long equation. 0.7870 times 23.98 AMU plus 0.1013 times 24.99 AMU plus 0.1117 times 25.98 AMU. All right, that's going to equal the atomic mass. So we'll say magnesium atomic mass. All right, let's go back to order of operations. PEMDAS, parentheses first. Since it's multiplication, let's write the number of sig figs. So this is 4 sig figs. 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 When you see something like that, right? Typically the answer is going to be 4 sig figs, but not necessarily all the time. I guess in this case it will be because everything's exactly 4, but we'll have to do the math for each and every one. So 18.87226. So let's put a line there. This is 0.1013 times 24.99. I got 2.531487. This is in atomic mass units. 0.1117 times 25.98. I got 2.901966 atomic mass units. All right. So again, there's four and then four. But now when we do addition, we have to do the least number of decimals. All right. So here, since the overline is over the seven, this is two decimals. The overline is over the one, so that's three decimals. Here, it's over the one, this is three decimals. So we have to have two decimals in our answer. Let's add all that up. 18.87226 plus 2.531487 plus 2.901966. I got 24.305713, two decimal places. So 1, 2, put the line here, and this is going to be an AMU. But since we have two decimal places, it's going to be 24.31 AMU, atomic mass units. And if you look at the periodic table, that is the atomic mass of magnesium right there on the periodic table. All right, well, that's it for today. Thank you very much. And yeah, practice hard, dedicate some time, practice, ask questions, and yeah, thank you very much. And I will see you next time.